I'd like to take a look at a couple of problems from section 2.3 with you. These are some limit problems that require a little bit of algebra to find the answer that we'll be looking for. And these two examples have something in common. And let me talk about it for the first one, and we'll see it come up again in the second one here. So the problem on the left here, we have the limit as x approaches 3 of x squared minus 2x minus 3 over x minus 3. Okay, now if you substitute in the value 3 here, okay, which is a fine instinct to have, is just to, hey, maybe I can just plug in 3. For many types of functions, that will give you the limit you're looking for. There are exceptions, so we need to be careful. If we do that in this case, though, what we're going to get is 0 over 0. And this is an example of something called an indeterminate form. What that means is the form that it's in, if we go to evaluate it, it does not give us information about the limit. Okay, now, and a very important thing to remember when you see that indeterminate form is that does not mean that's the end of the problem. That doesn't mean we can't find a limit, and it also doesn't tell us any particular answer just from knowing that it's of that 0 over 0 form. A common mistake I see some students make is they'll get to that 0 over 0 form and they'll say, well, it's undefined, or they'll say the limit's 0, or it's 1, or all kinds of, different answers. But what happens to be true is 0 over 0 just doesn't give us an answer, but it also doesn't mean there isn't an answer. It means we need to try some other way to get at that answer. And for this example, and also for the next one we'll look at, we're going to get there using some algebra. Okay, so what we're going to do is factor. So we have x squared minus 2x minus 3. That's going to factor as x minus 3 times x plus 1. We still have that x minus 3 in the denominator. Okay, and now notice we have a common factor. We have x minus 3 and x minus 3. That's really no coincidence. If you think about it and plug in 3 here, we're going to get 0 here and 0 here. Okay, so you can understand what's happening here by thinking back and saying, hey, the reason we were getting 0 over 0 is because of that common factor. More specifically, it's because they have a common factor, which is 0 when it's evaluated at x equals 3. So our limit here will be the same as this limit. And now we've reached a point where we have the limit as x approaches 3 of x plus 1. We can substitute in there because that's a polynomial, and we no longer have any kind of 0 over 0 problem that we saw before. Okay, so we arrive at our limit, which is 4. And just to go back to something I said earlier, there's no way from knowing that it was 0 over 0 form that we would have predicted it to be 4 or any other answer. So this does not clue us into the answer, but it also doesn't mean we can't find the answer. All right, let's look at the next one. Here the algebra is maybe a little bit trickier. We need to get a common denominator. That's the way I'm going to do this. And by the way, again, 0 over 0 form. All right, so common denominator for these two fractions up here is going to be 5 times 5 plus h. Okay, so this first fraction is equivalent to 5 over 5 times 5 plus h. Second one, 5 plus h over 5 times 5 plus h. It's all divided by h. All right, now, we got to be a little careful here. We're subtracting, we've got this common denominator. Okay, we did that on purpose, right? We wanted a common denominator. And we're subtracting this entire thing here. So that means when we subtract, we need to be careful about our signs. We're going to have negative h over 5 times 5 plus h. And that whole thing is divided by h. Now I'm going to rewrite this because we don't like to have that complex fraction. So I'm going to write that as minus h, or negative h, times negative h over 5 times 5 plus h times 1 over h. Okay, and now it's a little easier to see that cancellation. So we've got the limit as x approaches 0 of now negative 1 over 5 times 5 plus h. Okay. We've reached a point here where now we can substitute in x equals 0. Okay, because we've got this rational expression. We no longer are getting 0 over 0. Okay, so it's okay at this point to substitute in. And when we substitute in 0 for h, we're going to get negative 1 over 25. Okay, that's our answer. And so again, as I said in the previous example, there's no way that back at the beginning of this problem, just knowing that we had a 0 over 0 form, there's no way we would have predicted that this would be our limit. Okay, but we were able to get to that limit using some algebra. All right, that's the end of these examples. I hope you found them helpful, and I'll see you in the next video.